Thanks for joining this joint seminar. I'm Karsten Kohler. I work at University of Leeds, and I did EPOG about 10 years ago. So I graduated in 2016. So it's been some time. I definitely skipped some joint seminars, so I'm grateful that you attended this one. Yeah, what else? I think maybe I've met some of you in this online session where I presented the DIY macro simulation website. But otherwise, I don't really know what you're doing these days in the EPOG program. So I have no idea whether this is going to be interesting for you or not. But Daniel Lang told me that you might be learning a little bit about agent-based modeling in some of the modules. So there could be a connection there. So I hope it's somewhat interesting and useful for what you're doing here, what I'm presenting today. Yeah, I think I'm going to sit. Yeah, so this paper is joint work with Joe Michel from University of the West England in Bristol and Ayosia Fageme from University of Geneva. Title is Analytical Heterogeneous Agent Macro Model of Concentration, Markups, and Falling Labor Shares. Probably a bit too long and complicated, but I'll try to break it down a little bit before we go into the technical parts. So in terms of motivation for this paper, we have two types of motivations. The first one is a methodological motivation, which is that macroeconomic agent-based models are becoming increasingly popular. There's now a pretty established literature on this, but these models are also becoming increasingly complicated. And yeah, depending on how much exposure you had to macroeconomic agent-based models, you might feel that it can be quite complicated as a reader of a paper to really understand what's going on in these models. And this is also acknowledged in the literature. It's sometimes called the black box problem. The fact that you get a lot of simulation results, but especially as an outsider, a person who's not working with these models, you don't really know exactly what mechanisms generate these outcomes that you see in the simulations. And this also creates somewhat of a gap vis-a-vis smaller scale analytical macro models that you might also study in the EPOG program, small scale Kaleckian models, for example, or also new Keynesian models. If you look at these models, they tend to have analytical solutions. You can work out mathematically what's going on. So that's quite different from what we find in the macro agent-based models. So we have a gap here between these two types of macro models. And one motivation for our paper was to ask how can this gap be bridged? Is there something in between a complex agent-based model and a much simpler mathematical model? And then the second motivation that we have for this paper is an empirical one. There is a relatively established empirical literature on the one hand, the rise in the aggregate profit share that has been observed in many countries. Am I supposed to sign something now? Can I do this later? Okay. So the rise in the aggregate profit share over the period roughly from the mid-1970s to the global financial crisis, there's a big literature on that, and you will have heard about this for sure. But at a slightly more micro level, there's also literature that shows that there's a change in the distribution of markups at the firm level. And we show this here with some data from Compustat for US listed firms, where you can see the distribution of markups in 1980 and then in 2019. And what you can see is that the distribution has become more right-skewed. So you can see here here this gap. This illustrates that the distribution is becoming more right-skewed, and we're getting a heavier right tail here in the distribution of markups. And sometimes in the literature, this is called a has been associated with the rise of the superstar firms. So some really big firms like Amazon, Apple, that tend to have very large markups, and at the same time also have high market shares. So they make up a greater component of aggregate output, and at the same time they also have high markups. And as they have higher markups, they also tend to have high profit shares. So there is this empirical literature that has argued that some of this rise in the aggregate profit share is driven by a reallocation of market shares towards these large superstar firms that tend to have high profit shares. And so in a way there is an underlying microeconomic explanation behind this fall in the aggregate labor share. And this has to do with concentration dynamics. So the fact that we have now a smaller number of these really big superstar firms that are dominating certain markets. And then the rest of the story you are probably well familiar with from a more kind of Keynesian, post-Keynesian perspective, is that this fall in the aggregate labor share is then linked to weak aggregate demand and economic stagnation. And so our second motivation for this paper is to ask the question, can we model these macro interactions whereby the aggregate profit share is partly driven by concentration dynamics at the micro level, which then has follow-up effects on aggregate outcomes such as the aggregate rate of capacity utilization, the aggregate growth rate. So these are the two motivations for this paper. And what we do in the paper is to build a small-scale macro agent-based model of these micro concentration dynamics and their macroeconomic effects. And we first built an agent-based version of the model, and I'll tell you in a minute what we mean by that. And then we construct a simplified version of this agent-based model, which we call an analytical heterogeneous agent model, in which we abstract from some of the direct interaction that we have in the agent-based version of the model, and we simplify that, and we use a single equation to simplify that part of the model. And with this simplified heterogeneous agent model, we can then derive some key properties mathematically, and we can show that the simplified version of the model doesn't generate exactly the same results, but very similar results. So it can be regarded like an approximation of the agent-based model that has the advantage that you can really pin down exactly what's going on in the model. And in that way, you avoid a little bit this sort of black box problem that I mentioned in the beginning. So in terms of contribution, we build a bridge between these fully aggregate models, the textbook models, textbook post-Keynesian type of models, and the full-blown agent-based models by building this kind of hybrid model that's somewhere in between. And we also formalize a simple theoretical explanation for the microeconomic origins of the fall in the aggregate labor share. So these are, in our view, the two contributions of this paper. Okay, let me try to explain the model verbally before I go into some of the equations. We have heterogeneous firms in this model. Sort of that's the key form of heterogeneity we have. We have firms that are heterogeneous in terms of their size. So in terms of the capital stock, the profitability, the market shares, the firms differ from each other. They can be big firms, they can be small firms. And the bigger firms in the model, they benefit from lower unit cost. So there's some kind of economies of scale mechanism in the model whereby the bigger firms tend to have higher labor productivity, and while paying essentially the same wages as the other firms with lower labor productivity, and in this way they benefit from lower unit costs. And this gives the bigger firms a competitive advantage, so they can charge lower prices relative to their competitors. And because consumers are assumed to be price sensitive, the bigger firms that have the price advantage they get higher market shares because they can attract more consumers. And we then assume that firms with higher market shares take advantage of these higher market shares by charging higher markups. So they believe that they can afford charging higher markets because of the fact that they're otherwise very price competitive and they can attract enough customers. And by charging these higher markups, the bigger firms, of course, also become more profitable. And then we have a pretty standard Kaleckian type of investment function in the model, whereby an increase in profitability leads to more investment. So the more profitable firms, they also invest more. And this creates, under certain conditions, in a way, a runaway effect, where once a firm has gained an advantage, it can attract more customers, it can become more profitable, it can invest even more, and by investing more, it becomes bigger, and it benefits even more from these economies of scale. And so, under certain conditions, this mechanism creates an endogenous change in the size distribution of firms, where you could start from a size distribution of firms where the firms are all equal in terms of size. But then due to some small shocks in the model, at some point a dominant firm will emerge and will become much bigger than the other firms. And this will eventually become some kind of superstar firm. And so we get a tendency towards concentration in the model, where then this big firm tends to have a much higher market share than the other firms. And this big firm also tends to have a much higher profit share than the other firms. And this tendency towards concentration at the micro level then drives up the aggregate profit share. And the increase in the aggregate profit share causes a fall in aggregate demand, because we're assuming a wage-led type of demand regime, and this fall in aggregate demand then leads to a fall in the aggregate growth rate as well. So that's the story of the model in a nutshell. And I'm going to go a little bit into the model itself now. And the way we structure this is we first present the macro component of the model, then the micro component or micro block. Then how we aggregate from the micro level to the macro level, and then the dynamics of the model. So in terms of the macro side of the model, this will probably look familiar to many of you. So we have a homogeneous good that can be used for both consumption and investment. And so total output is given by consumption and investment. And we are normalizing all these variables by the capital stock. So lowercase u is the aggregate rate of capacity utilization, and C is the consumption rate, so consumption over capital stock, and G is investment over the capital stock. Then with respect to consumption, we assume a simple Keynesian consumption function with a constant marginal propensity to consume out of wage income. So here, this is the marginal propensity to consume, CY, and U multiplied by 1 minus pi. This is basically the wage bill. Yeah, so pi is the profit share, 1 minus pi is the wage share. So wage share multiplied by the rate of capacity utilization is the wage bill. And yeah, then there's a constant marginal propensity to consume out of this wage income, and this gives us aggregate consumption. And in this model, the household sector is not disaggregated. Yeah, so we just have an aggregate household sector, and this is why we only need this aggregate consumption function, and otherwise we don't worry about heterogeneity among households. That's already the macro block. So this brings me to the micro block. And like I said in the model, the main disaggregated sector is the firm sector. Yeah, so we have n firms in the model. They're indexed by the letter I. And we have a bunch of identities here that are helpful to just sort of memorize. Hopefully, I don't know if you can memorize all of these symbols during my presentation, but I'll present it anyway. And see how, otherwise you can ask me later if you don't remember some of these definitions or symbols. But so we have the firm level capital stock K that follows a standard law of motion. So with this is the investment rate, GI, this is the firm level investment rate, so that translates into a higher capital stock over time. And then we have an important variable here, SIT, that's the relative firm size. So that's the capital stock of firm I over the aggregate capital stock. And we will see in a few minutes that this is an important variable in our model because firm size is an important factor behind productivity and ultimately also market shares. The market shares are defined as the output of the firm divided by total output. And we use the symbol Q for that. And then we have the firm level rate of capacity utilization, so that's UIT, so that's output over the capital stock. And you can see that we can also write this as market share of the firm, QIT, multiplied by the aggregate rate of capacity utilization, so UT is the aggregate rate of capacity utilization, divided by the relative size of the firm in the previous period. So one way of thinking about this is that we have a certain aggregate rate of capacity utilization, and this is then allocated over the firms based on their market shares. Yeah, so that the firm level rate of capacity utilization is essentially a function of how much capacity utilization do we have in the aggregate, and then what's the market share of the firm. And the higher the market share of the firm, the more of the sort of the greater the proportion that this firm will get from the aggregate rate of capacity utilization. Then we have two more definitions here. Pi is the firm level profit share, and R is the firm level profit rate. And the firm level profit rate is given by the profit share times the utilization rate. Okay, some relatively boring definitions, but some of them are important for what comes next. Now it gets a bit more interesting because now we're making some behavioral assumptions about what these firms do. And we use a Kaleckian investment function in this model. So we have investment being a function of some autonomous component, which you can think of as animal spirits. So that's gamma 0, plus a term that contains the profit rate. Yeah, so investment is positively related to profitability at the firm level, and then also the rate of capacity utilization. Then we assume that the firms do markup pricing. So they set prices based on a markup tau on the unit labor cost. And unit labor costs are given by wages divided by productivity. You can see here, for the wages, we're not using an I subscript because we're assuming that the wages are homogeneous across firms. Yeah, so this is a simplifying assumption that we make. We assume that the firms, they all pay the same wages, despite the fact that the firms have different levels of productivity. So delta I is the labor productivity, and this can differ across firms. And this will ultimately be the main source I guess it is the main source of price differences in the sense where that the more productive firms, they have higher labor productivity, but they pay the same wage, and this gives them a competitive advantage. The implied profit share from this setup is given by the markup divided by 1 plus the markup. I'm sure you've seen this equation before. This is kind of a standard result that you get when you assume this kind of markup pricing equation. Okay, so another key behavioral component in the model is this economies of scale mechanism that I've talked about before, which we formalize in an extremely simple way by assuming that the labor productivity delta is positively related to the capital stock of the firm. Yeah, so we're assuming that the bigger firms, in terms of their capital stock, they have higher productivity. And there is a literature on this that goes back to Arrow and even Kaldor. They had this idea that there's sort of learning by doing effects, or like some kind of embodied technical change, whereby investment over time leads to innovation and increases in productivity. There's also more recent literature on this, which also argues that this can also be related to IT or ICT, information communication technologies, where the bigger firms tend to benefit more from the ICT revolution because they rely more on computers, and the prices of computers or all sorts of information technologies have decreased extremely rapidly over the last 20 years. So it's the bigger firms that benefit more from these ICT-related productivity gains. So there's various arguments that can be made to justify this assumption. But of course, the way we formalize it, it's very simple. But this is to some extent intentional because we want the model to be relatively simple. We then assume that at the aggregate level, the nominal wage growth so the nominal wages grow in line with the aggregate growth rate. So because of this previous assumption here, we will have productivity growth in the model. And with productivity growth, we will also need nominal wages to grow, because otherwise we might mechanically introduce changes in the aggregate labor share, whereby the aggregate labor share either converges to 1 or to 0. So we need to, in a way, balance out this increase in productivity with an increase in wages, so that we don't mechanically have the profit share to converge to 0 or 1. And the way we do this is by assuming that the productivity growth is different across firms based on the size, but the wage growth is uniform across the firms, and the wages grow in line with aggregate productivity. And this means that an individual firm that may temporarily grow faster than the aggregate growth rate, in that moment benefits from these economies of scale, because it means that the wages that it has to pay, they grow slower. They grow at the level of the aggregate growth rate, while the individual firm grows faster. And this is then what creates a price advantage for this firm that grows faster than the other firms. And this is how the superstar firms ultimately in this model capture market shares, because they tend to grow a little bit faster than the other firms, but their costs only grow in line with the aggregate growth rate, and then they benefit from this cost advantage. And then I think the last key behavioral assumption we're making here is this one, the last equation, which is that the markups are assumed to be positively related to the market shares. So the firms believe that when their market shares go up, they can charge a higher markup. They take advantage of these higher market shares by charging higher markups. Okay, so these are the key assumptions in the behavioral micro block of the model. And then coming to aggregation, we aggregate the micro variables in a strict way. So we literally take the weighted averages here. So for example, to calculate the aggregate profit share, we take the weighted average over the firm level profit share, and the weights here are the market shares. So this is in literature sometimes called exact aggregation, because it's literally like the correct aggregation. There's no approximation or anything like that. And this is also a nice feature of this linear Kaleckian investment function that we use, is that you can aggregate this investment function And the aggregate version of the investment function, which is this, is the direct counterpart to the micro-level investment function. So here we have the aggregate profit rate and the aggregate rate of utilization. And this is possible because it's a linear investment function. So once you have nonlinearities, then aggregation will no longer be possible in this way. So yeah, to some extent, this is a nice feature of the model because of the fact that we set it up in a way that allows us to perform this exact aggregation. When it comes to the aggregate markup, with the aggregate markup, it's not entirely clear how you define the aggregate markup because the aggregate markup is not really a well-defined concept. Yeah, the aggregate profit share is clear what the aggregate profit share is like total aggregate profits over total output. But in the case of the markup, it's not clear how you aggregate it, so you need to come up with a definition. And here we use this definition. We just take the weighted average over the firm level markups, and we use the lagged market share as the weight in this weighted average. And we can already at this stage derive an interesting result from this model, which is that the aggregate markup in this model will be increasing in market concentration if you define market concentration as the variance of market shares. So we can use the equations. You basically use this equation here for the markup, and you use the equation for the aggregate markup. You can work out that the aggregate markup will be a function of the variance of market shares. And as you get higher concentration, the variance of market shares will increase. And in this model, this will drive up the aggregate markup. Yeah? So in a way, at a very elementary level, already just by making this assumption here, that the markup is positively related to market shares, you get the result that the aggregate markup will be increasing in market concentration. Okay, there's two more equations that we need to close this model. One is a law of motion for the relative size of firms. And we can just use the definition so the definition of the relative size of firms was this, micro level capital stock over the aggregate capital stock. If you combine this with the law of motion for the capital stock, you can show that the law of motion for this relative firm size is this equation. Yeah, this is just an identity. And the second equation that will determine the dynamics of the model is an assumption about how market shares change over time in the model. And here we assume that market shares are negatively related to the relative price, where the relative price is defined as the firm level price divided by the average price. So effectively what we're assuming here is just that consumers are price sensitive. They tend to go towards the firms that charge the lower prices, and thereby the firms that charge lower prices, they get higher market shares. At this stage, we are just claiming here that there is this functional relationship whereby market shares are negatively related to the relative price, and then we will consider two different equations or ways of specifying this market share equation, and one will be the agent-based version and the second one will be the heterogeneous agent model. So let me show you the agent-based closure of the model first. So for this agent-based version, we assume that we have bilateral matching of buyers and firms on the goods market. And this is how the market shares of the individual firms will be determined. So because we don't have in this aggregated household sector, the way we do it is we distribute aggregate consumption evenly over a certain number of households. So we now assume we have NH households, and we work out the aggregate consumption, and then we divide aggregate consumption by the number of households. So every household gets the same amount of consumption demand. And then we initialize the model such that in the beginning, each firm gets the same number of buyers. And then we have a search and matching algorithm where a certain share of buyers picks a subsample of the firms in the model, compares the prices of these firms, and then switches to the cheapest firm. If they already were connected to the cheapest firm, then they stay with it. But if there's a cheaper firm, then they switch and buy from the cheaper firm. And then there's another share of buyers that randomly switch to another firm. So they don't pay attention to prices. They're a bit more idiosyncratic. They just walk around and then, okay, I'm going to buy here. So there's a certain random element also in there. That, like, even a firm that may not have the most competitive price still has a positive probability of getting a buyer, because some people are like that. They don't care about relative prices for whatever reason. And then there's the remaining share of buyers. They just stick with the current firm, and we can set these parameters, of course, to simulate a model where the consumers are more price sensitive, or we can simulate a case where the consumers don't care so much about price. So we have these parameters that allow us to parameterize this a little bit and play around. And with this matching protocol, we can then work out the market share for each individual firm. So they get a certain amount of consumption demand, and they also get a certain amount of investment demand from the other firms. And in this way, we can work out the market share for each individual firm based on this agent-based search and matching mechanism. Let me show you what happens when we simulate this model. So this is the agent-based version of the model. We call it agent-based because of the fact that this matching protocol involves direct interaction between agents. So I'm not going to go too much into the parameters, so let's just look at what happens here. So we initialize the model so that in the beginning all of the firms are identical. So they start here from having the same price. And then you can see that for a lot of firms here, there's a divergence whereby these firms charge much higher prices than those two firms here at the bottom. And those two firms here at the bottom, the black one and the red one, and later also there's another firm that enters the pool of the superstar. So this green firm at some point becomes a superstar firm by severely lowering its price. And in the end, we have effectively these three firms here being the most price competitive firms. And then you can see correspondingly the market shares. The red, black, and green firm, these firms tend to have a much higher average market share than these firms here at the bottom. The firms at the bottom, they tend to have a below average market shares because their prices are just much higher. And then we can also see that these firms, the superstar firms, become much bigger in terms of their relative size than the other firms. So their capital stock makes up a bigger share of the aggregate capital stock. And finally, we can see here that the profit shares of these three dominant firms or superstar firms, however you want to call them, is also on average much higher than the profit shares of the firms that have lower market shares. And we can also plot the distribution of markups, and we can see that over time the distribution of markups becomes more right-skewed. So we start here from this symmetric distribution of markups, so that's the black line, which is initially symmetric. And then I plot the distribution as it changes over time. So I don't know, the blue one here is, for instance, after about 120 periods in the model, we get a heavier right tail here. And this reflects the three dominant firms that have the much higher markups. And then lastly, we can see what happens in the aggregate. So the red line here, sorry, this is a little bit, resolution is a little bit poor here. So the red line, this is the aggregate profit share. and you can see that the aggregate profit share goes up, and the black line is the aggregate markup. So both the aggregate markup and the aggregate profit share go up. And this is because of, well, essentially because of this tendency for these superstar firms. On the one hand, their markups, their profit shares go up, but also their market shares go up. So they make up a greater proportion in the aggregate. And as a result, the aggregate profit share gets driven up. And then the last aggregate result that we get from this, because our model is wage-led, we get a fall in the aggregate rate of capacity utilization, and we also get a fall in the aggregate growth rate. So these are the macro outcomes that this model generates. Okay, I'm going to skip this one. So this was the agent-based version of the model. Now, like I said in the beginning, one objective of our paper is to simplify the agent-based model and replace it by something that we can study analytically. So that's what we're doing now. So in this, when we call this heterogeneous agent model, HAM, in the heterogeneous agent model, we replace this bilateral matching algorithm on the goods market between the buyers and the firms with a reduced form market share allocation equation. So we just have a single equation here where we assume that the market shares Q are negatively related to the previous period's market share and positively related to the relative size of the firm, and otherwise they are determined by a random variable epsilon. So let me explain the reasoning here behind this equation. Remember that previously we had said at a general level, we had said that market shares are a function of the relative price. And you can show, I don't have it in the slides here, but in the paper we show it in the appendix, you can show that the relative prices are a function of the relative size of the firm and the market share. Why are the relative prices a function of the relative size and the market share? They are a function of the relative size because of the economies of scale mechanism. So firms with higher relative size, they have higher economies of scale, and therefore they have lower relative prices. And by contrast, firms with a higher market share, they charge higher markups. And because markups are also a component in the pricing equation, the firms with the higher markups, they tend to have higher relative prices. So that's why size and market share are the key arguments in the equation that determines relative prices. And based on this fact, this is why we use this linear equation with market share and relative size as the two main arguments in the determination of market shares. And we have a negative sign here in front of this zeta 1 coefficient because of this negative effect of markup pricing on competitiveness. And we have a positive coefficient zeta 2 which captures the positive effect of economies of scale on competitiveness. And with this, we get a two-dimensional system of first-order difference equations in the relative size of the firm S and in the market share. And so we can analyze this system of equations mathematically. And yeah, this was not really possible with the agent-based model, because in the agent-based model we did not have a single equation for this determination of market shares, because the market shares were determined through this matching algorithm. So we can now use this version of the model to make some propositions and also prove them, which I'm going to keep brief, but for those of you who want to look into this, we have a long appendix with a lot of math. So here, one of the key results is that we can show that this aggregate markup in equilibrium is increasing in the variance of the firm size distribution. So that's this term here. This is the most important insight from this proposition. So what's going on here is that when there's this tendency towards concentration, the variance of the firm size distribution will become bigger. Because we get the superstar firms, and they tend to be bigger. They tend to be much bigger than the small firms. So the variance of the firm size distribution increases over time because of the concentration dynamics. And this drives a wedge between the average and the aggregate markup. And it will drive up the aggregate markup. And we can also show that this effect is stronger the stronger the economies of scale parameter. So if you go back to this equation here, we have this parameter beta, and this parameter beta determines how strong the economies of scale are. And if these economies of scale are very strong, so if we assume that firm size translates very strongly into higher productivity, then the concentration dynamics in the model becomes stronger, and then we also get stronger effects on the aggregate profit share from this mechanism. So this is a result that we can show mathematically with this heterogeneous agent version of the model. Then we can also show what are the steady states of this model. I'm not going to go too much here into the detail because I think it's a bit boring to to present. But the bottom line here is we can write down these mathematical results. And then a last key result that we can show analytically is that so on the one hand we have a what I call here a no concentration steady state. So there is a steady state in this model where all the firms on average have the same size, so there is no concentration. And then there is a second steady state, which we call a concentration steady state, where a big firm emerges. And we can show mathematically the condition under which the no concentration steady state will become unstable. And when the no concentration steady state becomes unstable, then you get the concentration dynamics. And we can show that mathematically this condition needs to be satisfied for the concentration to occur. And economically, the two main factors that favor concentration dynamics in this model is the economies of scale. So the larger this beta parameter, the higher the chance that you get concentration dynamics at the micro level, which then drive up the aggregate profit share. And secondly, we can also show that if the growth regime of the model is either only weakly wage-led or if it's even profit-led, that also favors concentration dynamics. So macro regimes that are leaning more towards the profit-led side, they are more likely to exhibit these concentration dynamics. Okay, I'm trying to wrap up in the next couple of minutes. We also simulate the heterogeneous agent model. And like I said in the beginning, the heterogeneous agent model gives us qualitatively similar results. But one major difference that you can see here, this is the market shares. You can see that in the heterogeneous agent version of the model, we get one firm that dominates the model. So one firm here gets a market share of 70%. And these are all the other firms. So they get market shares of, I don't know, 5% or something like that. And so this is a bit different from the agent. In the agent-based model, it was a bit more complex. Yeah, in the agent-based model, we had these three dominant firms, and it was noisier, and there was a bit more going on here with these three firms dominating. In the heterogeneous agent version of the model, it's sort of more black and white in a way. There's this like one dominant firm, and then all the other firms they're much smaller than the dominant firm. But otherwise, in terms of the aggregate outcomes, the heterogeneous agent version of the model gives us the same results. Okay, so let me wrap up. So overall, this heterogeneous agent version of the model produces qualitatively similar results to the agent-based model. In both cases, we need sufficiently large economies of scale for concentration to occur. And once concentration occurs, this will drive up the aggregate markup. And once the aggregate markup goes up, everything else is the same. We get the same aggregate effect. Aggregate markup goes up, aggregate profit share goes up, demand goes down, growth goes down. However, this agent-based model allows for slightly richer modeling of the concentration dynamics because of the fact that we get the multiple dominant firms, which is probably a bit more realistic for most markets. And the effects of this economies of scale parameter are also more gradual. So you can raise the economies of scale parameter in the agent-based model, and you will reach sort of gradually more extreme versions of concentration. And this is different in the heterogeneous agent version of the model. There's basically a phase transition. There's a critical value for the economies of scale parameter, and then you either have no concentration at all, or you get full concentration, and there's nothing really in between. So in that sense, the heterogeneous agent model is sort of not as rich. Yeah, it's a bit more kind of stylized, which is in a way not very surprising because it's a simpler model. And then the agent-based model also gives you some more things you can play around. So we also have these other parameters, for example, that determine the price sensitivity of consumers in the matching. And you can also play around with these parameters, and they can also affect the level of concentration that you reach in the steady state. So in that sense, the agent-based model also has more parameters that you can use to calibrate the model if you wanted to match some more like real-world data on market concentration. Okay, so let me conclude. Overall, we provide a model to study how micro-level concentration dynamics lead to falling labor shares at the macro level. And we show that the sort of key results of an agent-based model can be retained in a simplified analytical version of the model. And in this way, we're trying to build a bridge between the sort of more traditional aggregate macro models and the full-blown agent-based models. And in terms of the main takeaways from our particular model, we emphasize the role of economies of scale as a key driver of concentration. We show that changes in market shares towards more concentration can impact functional income distribution at the macro level. And in this way, changes in the cross-sectional distributions matter for macroeconomic outcomes, which I think is interesting, especially for you who have probably studied Kaleckian models. This is just simply something you cannot really capture in a Kaleckian model. In a Kaleckian model, you have an aggregate markup, and then there's a story, the aggregate markup is somehow related to concentration or something like that, or the degree of competition. But we don't really model that in any detail. And so here we have a model that kind of unpacks that a little bit and shows how differences across firms and the firm size distribution and markup distribution and so on, they can matter for macroeconomic outcomes. So that's sort of what we're doing in the paper, and I look forward to your feedback.